Hey guys, this is CubeHeads101, and today I'm going to be teaching you how to solve the 3x4x5 cuboid that you see right here. Now, I'm going to break this video up into several parts. First, I'm going to tell you the basics of this cuboid, the strategy we're going to use. Then I'm going to teach you how to solve it using knowledge from a 3x3x4, and then I'm going to teach you how to fix parity as well as doing the outer layers. Now, I assume you know how to solve this. If you don't, then maybe you can still follow along the video because I'm going to be using this a lot, but it will be a lot easier if you already know how to solve a 3x3x4. And if you know how to solve a 3x3x4, you will only need to learn one new algorithm in order to always be able to solve this. And if you don't know how to solve a 3x3x4, then there are only 6 algorithms you need to learn, and 7 if you want to make your life easier. But 6 that you absolutely need to learn. And I won't be telling you the algorithms in the video, I'll just be referring to them by their name. And in the description I will have the name of the algorithm and what the algorithm is. That way I won't have to tell you the letters for the algorithm each time. So basically, this is how it works. This is a 3x4x5 cuboid. Now the two numbers with the same parity are 3 and 5. They're both odd. The smaller of those numbers is 3. So that means that when you shapeshift it, the 5 turns into a 3. So once you shapeshift this, it turns into a 3x4 and then the 5 turns into a 3. So 3x4x3, which you could also say as a 3x3x4. So once you shapeshift it, it turns into this. And once you solve this, you're back in its cuboid form. So when you mix up a cuboid, you want to figure out what you can turn. What I like to do is the face that is allowed to do non-180 degree turns, the face that can do 90 degree turns, I like to put on top, and that's what you should do if you're following this tutorial. And I always make that either the white or the yellow face. So I like to hold it with white on top, green in front, and I always make it so that way the face that's on top can do 90 degree turns. If I put this on top and try to do a 90 degree turn, I won't be able to do another turn. So that is not a valid turn for this puzzle. Moving on. The next thing you need to know about solving a cuboid is how to scramble it. You always want to scramble the cuboid in its cuboid form before you start shapeshifting, because if you shapeshift before you start, if you start immediately shapeshifting, like if I do this, then or if I do this, then I'm no longer going to be able to mix these parts of the puzzle up. So basically, you want to scramble it as much as a cuboid as possible, and then from there you're going to start shapeshifting. So that is what I'm going to do. I'm going to scramble up this one, and I'm going to scramble up this one at the same time, so that way you see what I'm doing. Now, for the first step of solving this, we're going to solve the inner layers of what we're going to call the 3x3x4 part. Now, I'm teaching you a method that I've developed myself, so this is probably not the best way of going about it, but I can guarantee you will solve the cuboid every single time. So the first thing you want to do is, well, first you should learn your color scheme. Okay? So I know that the way I like to have it, when white is in front, white is on top, I'm going to have green in front, red on the right, orange on the left, blue on the back, and yellow on the bottom. So what you have to do is you have to make a cross here. So I'm going to put the green in front, red goes on the right, blue goes in the back, and orange is on the left. So I have this cross. And now I'm going to do the same thing here. So I'm going to put white on top. Okay? We know what the top is based on the very center sticker. Okay? White is on the top, so that means I need to put green in front. I'm going to put a green one. There we go. I need to put a red one on the left. Or I can put an orange on the left, red on the right. And then I'm going to put a blue on the back. There we go. The next thing I do is I use my corner insertion algorithm to bring the corners down to where they belong. Now, I'm not going to tell you what the algorithm is, but in the description it's going to be written as corner insertion algorithm. And what you do is you find a corner that belongs here. So in this case, this one doesn't belong here because the green is matched and the red is matched. And you want the red to be next to the green and the green next to the red, because when you bring it down, it's also going to flip it. So this is the piece that we're looking for. So I'm just going to use the corner insertion algorithm to get all the corners on this layer. I have now solved one whole layer on my 3x3x4. I'm going to do the same thing on this puzzle. Now the difference is on this puzzle, a corner, it consists of these two pieces. Now the way I mixed it, I must not have mixed it very well because a lot of them are matched. But we don't care about that. All we care about is getting a green next to the green, so we're only caring about the inner pieces. So this, I'm dealing with this blue, not this blue. If this were a green, we would still consider it a blue piece. So what I do is I bring it over the blue, and I know that there it's not going to work because it is, if it goes down, it's going to twist. But this one, if it goes down, it's going to twist, so it will work. As you can see, I have now inserted this corner. This happens to be matched, we don't care. We're only dealing with the inner part. So go ahead and do that to the rest of the corners on your bottom inner layer. I have now solved the inner part of the bottom layer. Now once again, some of these aren't matched, but that's because I'm not caring about these for now. All I care about is these. So I have this makes one part, that's the green. Then I turn it and I have one red. That's all I care about, because this corner, we're not caring about this piece, we care about this piece. Then you turn it again, I have all the blues, and I turn it again and I have the orange, because this is the corner piece. Next, you're going to want to do the layer above it. The first thing you want to do is put the corners. Okay? So there are two things that can happen. You can either have two corners next to each other that can be aligned, or two corners that are diagonally opposite each other that can be aligned. Okay? In this case, I have two corners next to each other that are aligned, so I align those, and then I'm going to use a T-perm to fix them. If the ones that are diagonal are the ones that are aligned, then what you do is you hold it so that way the one in the front right and the back left need to be switched, and you use a Y-perm. In this case, I'm going to use a T-perm. I have now aligned all the corners on this layer, and I happen to have solved the centers, but that is irrelevant. I'm going to do the same thing on this puzzle. I see that I have two greens aligned. What we're doing is we're looking at these for the corners. These pieces we don't care about. So I have two greens, I can align those, and that means that this blue and this blue, they need to be switched. So once again, I can use a T-perm. I have now aligned the corners on this layer. Okay? The next thing you want to do is align the centers. There are two algorithms you can use for this. There is the fish, which is going to switch two opposite centers, and then there is the edge adjacent swap, which is going to swap these two. Okay? Right now I see that this blue needs to be switched, and we don't care about this on the next layer, but on this layer we do. Because on the next layer, we're counting these as the solved part. But on this layer, you can't see what's over there, it's just inner mechanism of the puzzle. So on this layer, you do care about having a red piece here, but for these parts you don't. So I see that if I switch these two with a center adjacent swap, I will have the blue where it belongs and the red where it belongs. So over here, I'm going to do a center adjacent swap. I have now solved the two layers that I used to solve the puzzle. Now once again, we do not care about these. Okay? I see that the configuration I have, I can easily solve them by doing that. but that is irrelevant. We do not care about these pieces for now. What we want is these 6 to be solved, these 6 to be solved, these 2 to be solved, and these 2 to be solved. The next thing you're going to do is solve the bottom. These 9 pieces, the 9 inner pieces on the bottom, in order to have a 3x3x4 solved right over here. So I'm going to first show you on this. What I do is I make a cross. I see that I have the blue one already made, but I do not have this red one. So I'm going to put in that red one where it belongs. And I first see that this green is not where it belongs. So I take that green out. Now on this puzzle it twists this. So when I take that green out, I'm going to have to put it back down. So think of this as an elevator. This is going to go up, but if it goes up it's going to have to go back down, otherwise you are going to break some work that you did. So now that I put that up, I'm going to have to put it back down. And we have our greens aligned and our blues aligned. Now I have the oranges to align. So I'm going to align the oranges. The elevator went up. The elevator needs to go back down. So I need to put this red in where it belongs on the same side. Now I align the bottom, and I have made a cross with these 2 layers that matches on the bottom. I am going to do the same thing on this puzzle. So for this, once again, we do not care about these for now. We just care about these 9 pieces. Well, the crosses part, so these 4 pieces. So the first thing I'm going to do is look for a yellow-green piece. Right here I have a yellow-green piece, so I'm going to bring that around. Now what we saw is it rotated these, but we don't care about that because in this case it did solve them, but I'm still considering this solved because we don't care about these. It was a coincidence that these match up. Okay? And if you're solving this technique every time, they might not match up right away. So on this puzzle, for this part, you do not always need to use the elevator on the same side. So I'm going to bring that down, and I don't care that these twisted. Now I look for another piece. I have another yellow here. This yellow is the inner piece, so we don't care about this piece. To stress that we don't care, I'm even going to match it up with that side. So I'm going to bring it there. Now if you do use the left or the right side for the elevator, then you're going to have to use it again because it did break something. Okay? So if you use it on this side, it's not going to break anything because we don't care if these flip. But if you use it on this side, we do care if these flip. So I'm going to use it, but that means I'm going to have to use it again. So now I've matched that, I've matched the greens. What else do I have? I have a blue to match. I'm going to match the blue. Instead of doing it on the front, I'm going to match the blue this way. That way we unflip the elevator. Now the only thing we have left in the cross is this one. So I see over here we have one. We have different options. We can either put in a fake one and then a real one if we do it on the side where it belongs, or we can use the front because we don't care if the front elevator turns upside down. We don't have to turn it back up. So I'm going to do that. I have now made my cross. Once again, when you make your cross, you only care about these pieces. You do not care about the color of these pieces. You don't care about anything. I purposely did not match them to stress. So this does not need to match with this. This does not even need to be yellow. You just want the cross over here, which I have. Next, you're going to want to do your corner insertion algorithm. Your corner insertion algorithm is the same as before. So I take a corner, and for these we're going to care about the inner layers. We don't care about the outer layers, once again. So here is a piece. I'm going to put it where it belongs, over where it belongs, and then I use the corner insertion algorithm. Now you see on this puzzle, every time I do the corner insertion algorithm, it's going to flip these. So if I want to do it again, I'm going to have to do it on the same side. So this, I can't just use the corner insertion algorithm there. I'm going to have to bring that there, and then do the corner insertion algorithm. I have now solved the bottom 3 layers on that. We are going to do the same thing on this puzzle, only caring about the inner pieces. I do not know how to stress any more than I'm already doing that we only care about the inner pieces. So I'm going to bring this one in. Now you may notice that we don't care that these flipped, because what flipped also was these, but we don't care about that. So in this, we don't care if this flips, and we don't care if this flips, okay? Because if this flips, these flip, and we pretended we didn't even solve them yet. And if these flip, well, nothing really happens. So if these outer layers flip, we don't care. So on this puzzle, you don't actually have to do it on the same spot each time. I'm now going to bring that one right down from there to there. Now over here, it did flip because of how I did it. It flipped these. If you grab 2 layers, it is going to flip it. So now that means the next one I do, I'm going to have to do over the same spot. So this is a green. So I'm going to have to put it there to do these 2 layers, so I'm going to have to put it over the same spot once again. This is unflipped, and we have now solved the bottom layer. We don't care about these pieces. We don't care about any of these outer pieces. In fact, the only thing we care about right now is our 3x3x4 inside this part. So that's what we're doing, and you can see that looks solved. These don't, but we don't care about them. Now we're going to do what we did for the top layer. Do that once again. So if I look at the top layer on this puzzle, I see that I have 2 next to each other that are matched, and these 2 that need to be switched. So I use the T-perm. If there were 2 that were opposite each other, diagonally opposite, that were matched, I would use a Y-perm. In this case, I use a T-perm. I now have the corners on the top layer solved. We're going to do the same thing here. In this case, I didn't have to do anything. The corners were already solved. These 2 corners and these 2 corners. Next, you want to solve the centers. The centers consist of these pieces, and that is it. Because these pieces, we should already have our cross, okay? And these pieces we don't really care about. I take a look at this puzzle, and I'm going to see this blue right over here. I need to bring here. So to do that, I'm going to use a fish, which is going to switch these 2 and those 2. Now you see that these have swapped, so I'm going to have to do the next algorithm in the same direction. I see that these 2 I can switch using a center adjacent swap. I'm going to do that real quick. And I fixed the top. I have now solved this whole puzzle. I did not encounter parity. But parity is on this puzzle is an algorithm you're going to have to learn, because we're also going to have to use it on this. In this case, I see I'm going to use a fish to exchange this center with this center, because those are the ones we care about. These ones we don't care about for now. So I'm going to use a fish. Now I encountered parity right over here. We're going to use the parity fix algorithm. Since the parity is on this layer, because we don't care about this layer yet, we're going to grab 2 layers to fix the parity on this layer. It's also going to happen to fix the parity on this layer, but we don't even know that there was a parity here because we didn't solve anything here yet. So we hold it in the front and we do the parity algorithm. I have now fixed the parity and I have solved this whole inner part. Now, I have solved a lot more than that, but that was a coincidence, and I will go over how to solve all of it. So do not worry if your puzzle does not look like this yet. All you care about is that all of this is solved, all of this is solved, the whole inner part, everything but these layers should be solved. Just like this. At this point, what you want to do is you want to match these up. These ones and these ones. Now, you don't care if you break anything on this layer. You just want to match these ones to where they belong, and you do care if you break these. So this should be very intuitive. I'm not going to go over every case because I think that it's something that you should be able to figure out if you have enough experience to solve this cube in general. But basically, what you're going to do is you're going to get these ones matched, all these 4 pieces matched without breaking anything that you've done. Well, now what we've done is this band, those 2, and those 2. So those are off limits to break. Everything else you can do however you want. In this case, what I'm going to do is I see that these 2 need to switch and those 2 need to switch. So if I turn these upside down, this layer and this layer, then I can switch them and then I can bring them back up. And then I can switch the bottom. Now, I did break some stuff that was solved, but that's not the point. The point is that you have this band solved and these. So now you should have a band in all directions solved. You should have this band solved, you should have this band solved, and these pieces might not be solved yet. Now the way you're going to solve these corners is the same way you're going to solve these corners. And I'm thinking of these as corners because first you're going to solve the inner part. Think of that as a puzzle. And then once that is solved, you're going to solve the outer part. In order to show you the inner part, I'm going to show you the outer part on this because it is the exact same thing. The only thing is when I turn the U face, you're going to turn 2 faces because you want to turn this. Now to do this, first we want to make the cube symmetrical. In my case, the cube is already symmetrical. I have those like that and those like that. Everything is symmetrical. If the cube is not symmetrical, then you're going to have to use a corner cycle. I have the corner cycle algorithm in the description. A corner cycle works like this. I will show you on the cube. And basically you always grab on this layer as few as you can. So I'm going to show you a corner cycle on this one, and then I'm going to show you a corner cycle on this later. What the corner cycle does is this. The corner cycle cycles this corner, and this corner. Now, as you can see, this cube is not symmetrical. When this cube is not symmetrical with respect to the corners on this layer, you're going to do it on that layer and then solve these layers, and then you're going to do it on these layers. Now I'm going to go over what to do when you've solved everything except for these corners right over here. I'm calling these corners, by the way, and it is not symmetrical, so you cannot just use parity algorithms to solve it. You're going to have to use the corner swap cycle that I've showed earlier. The corner cycle I showed earlier, and if the problem is it's not symmetrical on this layer, when I say you make sure you turn this layer. You can also turn the top 2 layers, it won't matter. Now, there are 2 ways to do this. The way I do it is it's going to bring this corner, which is the front left bottom, front left down corner, it's going to bring it here, and then it's going to bring this corner here, and then it's going to bring this corner back here. So in this case, it's going to solve it. Now that is the only algorithm I'm going to put in the description. If you need to cycle them the other way, there are 3 things you can do. You can either do the algorithm twice, you can learn the inverse of the algorithm, or you can learn the mirror image of the algorithm. But I'm just going to go over one of them because I think you can figure out the rest on your own. So the algorithm is in the description of the video, but I'm also, because this is probably the hardest part of the puzzle, going to go over the letters as I do it. So in this case, it is the outer layers, so when I do U, I'm going to do this. So I'm going to do a U, and then what I can grab on the R squared, you always grab the minimum you can with R, but in this case the minimum is 2 layers because I can't turn this. So it's going to be a U, R squared, U prime, L squared. Then I'm going to do another U, R squared, U prime, L squared. Now I'm going to do an F squared. And then I'm going to do an R squared, but when I do an R squared, I grab this. And then an F squared. Now I'm going to do an L squared, U, R squared, U prime, L squared, U, R squared, U prime, and then I'm going to do an F squared, R squared, F squared, and the puzzle is solved. Now when I did just the R squared, sometimes the puzzle locks up. There are different solutions online for what to do, but what I do is I do a T-perm in order to solve this back into its cuboid form, then I do the R squared, and then I undo the T-perm. I now have these symmetrical. What I see I can do is I need to bring these greens to the other side. I need to bring these reds to the other side, and basically every piece needs to go opposite to where it is. So over here, if I switch these opposite, I'm already on a good start. So I'm going to look at the white face now, because all of the algorithms at this point are only going to involve squares. So it does not matter how you hold the puzzle anymore. I see that the easiest thing for me to do is to do the equivalent of an H perm on this face and then on this face. So that is what I'm going to do, because I see that these stickers are already solved. So I am going to do a parity fix algorithm that is going to take this there, I'm going to take this there, I'm going to take this there, and then I'm going to take this there, and then I'm going to do a fish to fix anything I broke. So think of these as, your parity fix, what it does is it takes these and it switches them, it takes those and it switches them. So that's what we're going to do. We're going to do our parity fix algorithm, and we're only going to grab the layers with the parity. After doing the parity fix algorithm, I noticed that I have switched these and these. So I'm going to do a fish to fix that. I have now solved this entire layer. I'm going to go ahead and solve this entire layer, doing the exact same thing. This needs to go there, this needs to go there. So first I'm going to switch those like that. Using the parity fix algorithm, it's going to switch two edges, and then I'm going to do a fish, and I have solved the puzzle. I have now swapped everything that I needed to swap, but I have also swapped two edges, so I'm going to do a fish. I've now solved the entire puzzle. The way I solve the outer corners is the exact same way you're going to solve the inner corners. First solve the inner corners and then solve the outer corners. So that's it. You should now be able to solve your 3x4x5 puzzle. If you have any trouble, or are there any cases you can't figure out, just leave a comment or message me, and I'll tell you how to get around that. But I think that with what I showed you, you should be able to always solve it. Thanks for watching CubeHeads 101. Subscribe and goodbye.